Hello. Okay, welcome back to your application or to your bridging mathematics. We will now proceed with your module 2 applications of your algebraic concepts. Okay, so we will now try to apply this one, and the application of this is in your problem solving. Okay, so we will first start with your unit 1 under your module 2 application of linear equation. Okay, so application of linear equation. So in this unit, you will be you will be able to translate the worded problems into equivalent working equation, and then you will be able to solve problem solving involving linear equation. So that is our learning outcomes for this unit 1. Okay. So before we will start, just a recall in your problem solving procedure, which is in your basic mathematics in your high school. Okay, so general procedure for solving problem solvings, is first is to read and understand the problem and identify what is being asked. Okay, so that is very important. You need to understand the problem, okay, and you need to know what is being asked in that problem. And then after that, assume a variable for each of the unknowns and describe what does it represent. And then of course draw figures needed to visualize the situation if that is needed. Okay, so that is also very important, because we cannot apply your equation or solutions of equations if you do not have equation. Okay, so in the first place, you need to translate your worded problem into a resulting equation. Okay, so that is why we need to have variables there. Okay, so again, assume a variable for each of the unknowns. So again, once you identify what is unknown or what is being asked, then try to assume a variable for that. If that is more than one, then you need to have more than one variables also. So one variable for each of the unknown. And then of course, for you to visualize that one, especially if the problem is talking about geometries or shapes and then figures, you need to have their figures. It is always better to draw your figures, and then formulate. Once you have your variables and then figures, you will now be able to formulate a working equation by relating these variables according to problem. So that if you will relate your variables, that's the time you will end up with equations, isn't it? And of course, once you have your equations, then you can make use of that, play around with that to solve for the unknown. And then of course, once you have your unknown, just like in solving this x and y values, you need to check that one to make sure that your answer is 100% correct. So check that one by substituting back to the values that you solved to the working equation that you had. Okay, so that is the general procedure for a problem solving. That could be a problem solving in algebra or trigonometry or any other problem solvings. Okay, so let's start with your linear equation. Okay, that is your unit 1 linear equation. And then of course, linear equation, the first type or common type of your linear equation is a linear equation with one unknown. If you say one unknown, you will end up there with equation that has only one variable. Okay, that has only one variable. And then of course, if this is one variable, then you only need one equation, isn't it? That is our rule in your solutions of equations. The number of equations should be equal always to the number of the variables. Okay, so let's have this example. Let's start with examples. That is how we will apply your algebraic concepts. Okay, so first, example number 1. A $350 is to be divided between Jones and Smith, so that Jones will receive $25 more than Smith. How much does each receive? Okay, so you have there at $350, wherein you are going to divide that one to Jones and Smith. And there is a given situation there. It says there that Jones will receive 25 more than what Smith will receive. Okay, so again, that is the first procedure. Read and understand. Okay, so let's say I already understand this one. What is the unknown? That is the procedure number 1. You need to know what is unknown, and actually you can find that one mostly on the end part or on the first part, but actually by merely reading your problem, you can figure that out. Okay, so in this one, how much does each receive? Since again, the $350 is to be divided, the unknown there is how much will Jones and how much will Smith receive. Okay, so that is the unknown. There are two. Okay, however, since let's try to answer that using one unknown, so we will be only using one variable for that. So let's say x. Okay, so that is now your procedure number 2. Assume a variable for each of the unknown. Okay, draw a figure, but actually you do not need a figure there. Okay, so that is what we are going to do. Let's say x is the amount received by Jones. Okay, let's say that is the unknown. That is the variable since we do not know that amount, isn't it? In the first place, we do not know that one. So let's say that is x. And then of course, we need to find out also later on your amount received by Smith. So you need to assume that one also. However, we will not use another variable since we are still on one unknown. Okay, we will be applying here one equation, one unknown. So you need to make use of the same variable, but do not say that that is also x because it says there that they are not equal. Okay, so it says there that Jones is 25 more than Smith. So if x is the value received by Jones, what is the value received by Smith? That is, if that is more than 25, so if x is by Jones, then x minus 25 is Smith because it says there Jones is higher 25 by 25. So if x is for Jones, x minus 25 is for Smith. Okay, we are done with your procedure number 2. But again, we do not need their figure, so you do not need to draw that. And then formulate the equation. Let's try to relate this one. Based on the given here, on the situation here, let's try to relate them. It says there that that is 350 in a total. So if I will add Jones and Smith, the money or yes, the amount received by them, if I will add Jones is x and then Smith is x minus 25. So if I will add this one, that should be equal to $350. So that is my working equation. That is how I created my equation, wherein in this equation I will play around with that, solve for the value of the variable that is the unknown. Okay, so that is your working equation. Now solve. So this is our solution. Since this is one equation again, I mean one unknown, you only need one equation, so we're good. We are ready to solve that. So just play around with that. Okay, so x, actually you can erase the grouping sign since there is no effect, since that is plus. So x plus x is 2x. That negative 25 will be going on the other side, so that will become plus. Okay, and then 2x, if you will add 350 by 25, that is 375. 2x, that is equivalent to 2x, so divide both sides by 2, you will have the x value as 187.50. What is that x? That is the use of your assumption, so that is always important. So again, always assume or always write down the assumption. What is that x? What is that y? What are those variables that you are using? Okay, without those one, I will not consider your answers. Okay, so always assume. Okay, again, always assume. So again, what is that x that we solve? Go back there. What is that? That is the amount received by Jones. So if we are talking about the amount and we are talking here about dollars, therefore, what is the unit of that? Always have a unit since this is problem solving. So x there is $187.50, which is, what is that? The amount received by Jones. And then is that all? No, not yet, because we need to find out both of them. Each, it says there each. So I need to go back there. What is for Smith? That is just x minus 25. So x minus 25 equals, x is $187.50, subtract 25 there, that will be $162.50. That is the amount to be received by Smith. Okay, so just like in your solutions of equations, it is always safe or better or best to check your answer by going back to the equation, substitute what we solved. Okay, so go there. Okay, substitute x. Okay, is that one? Substitute there. Play around with that. You will end up there with 350 equals 350, which is true. Therefore, we are 100% sure that our answers are correct. Okay, so that is the first example. Okay, second example. How long will it take Brianna and Mika together to plow a field which Brianna can plow alone in 10 days and Mika alone in 6 days? So let's understand this one. This is example of work problems. If you will try to open a book of algebras, there are a lot of problems, types of problems. Since I said, okay, you can apply this mathematics in any problem, isn't it? However, there are these common problems that are being dealt by algebra. If you will try to open a book, we have the work problem, age problem, and so on and so forth. But for me, okay, since we are not only on algebra, we have a lot of topics to discuss. All we need to do is solve one of these. And actually, once the important here is you know how to apply the procedure, the concept. Okay, you know how to translate the equation, the problem into equation, solve the values, and then know what is that values. That is the important here. It doesn't matter what type of problem are those, the procedures is still the same. Okay. However, okay, in work problems, okay, so first, this is example of work problem. Again, let's try to understand again. How long will it take Brianna and Mika together to plow a field which Brianna can plow alone in 10 days and Mika alone in 6 days? So we are talking here of plowing a field. And the question there, the unknown there is how long will it take both Brianna and Mika if they will work together to plow a field, which that field could be plown by Brianna alone, okay, in 10 days, and if that will be plown by Mika alone, that will be 6 days. The question is, what if they will work together? How long will that be? Since that is in days, therefore maybe the unit that we need to express our answer is in days. So that is the question. How long will it take both of them? So let's say that is the unknown. So let's say again, assume. Second procedure, once you understand and you already figure out the unknown, assume. Okay. So let's say X there is the number of days Brianna and Mika can finish plowing the field. Okay, since that is the unknown in the problem, isn't it? That's the only unknown. Okay, so I gave you here the K concept for work problems. So for work problems, the amount, okay, this is the K concept. Okay, this is the hint in your work problems. For work problems, the amount of work done in a day, if you are talking here of number of days, or the number of work done in an hour, weeks, or months, etc., whatever the time interval that you are considering. But in here, we are talking here of days. So let's say we will consider the amount of work done in a day or in one day is considered, which in this case, okay, in this case, Brianna can finish 1/10 of the job. Why? Okay, it says there, okay, go back to the problem. Let's say you have there a complete field. Okay, I will draw you a figure for that for you to understand. Let's say this is a field, the field. So, Brianna can finish that one in 10 days. So it means, divide that one by 10. Say 1, 2, 3, 4, 5. Let's say that is 5, and then divide that one, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are equal. Let's say this is divided equally. So it means that if this is the total field, Brianna can finish 1/10 of that. Since again it says there 10 days. So it means if he will be working uniformly, this whole field will be done in this part 10. 10 will be divided into 10 parts. Since let's say he is working uniformly. What we will be doing, he will be doing today, she will be doing today is the same as what she will be doing tomorrow, the amount, okay? So of course, the total will be divided by 10. So it means in one day, that is what she will be finishing. In another day, that is what she will be finishing. So in here, we will try to break down, okay? We will try to break down this one in a day. So what will Brianna finish in one day is, this one is 1/10 of the job, whatever job that is. But in here, in that case, the job is plowing a field. Okay, so 1/10. However, it says there, okay, while Mika can finish 1/6 of the same job in a day. So again, the same job. This is the same job. Now that is for Brianna, 1/10. Okay, 1/10 for Brianna. However, if Mika will work this one, she will be finishing in 6 days. So I will be dividing this one maybe in 6. So okay, so for 6. In one day, that is what Mika will be finishing. So what is that? That is 1/6 of the job or the garden or the field. Okay. So again, that is the K concept of work problems. We are talking here of any work, any job. Okay. So if let's say you are given a total number of days, or if that's in hours, then hours. Okay. If you are given the number of days for a certain person or anything or anyone can finish a certain job, consider 1 day or 1 hour or 1 week if that is the time interval. But in here that is days again, so let's try to focus on 1 day. So again, in 1 day, Brianna can finish 1/10 of the job, or 1/10 of plowing the field. And then Mika in 1 day also can finish 1/6 of that. Okay? So that is what we will be considering. So now we will make use of this concept in that assumption to create our equation. Okay, so it says there, okay, working equation. What will be finished by Brianna, since they will help each other together, isn't it? So 1/10 of the job is what Brianna can finish, and 1/6 is what Mika can finish. So they will help together, help each other. So I will add what they can finish in a day. And then the question there, how many days? Okay, that what they will be finishing in a day, multiply that one to how many days, so that they will finish one job, or the job one. Okay, that's why it is one. Why? They will be finishing one job. So again, that is what Brianna and Mika will finish together in 1 day. And do you know how many days? No, we do not know that one. So times x. All of that times x equals, what are they trying to finish? One job, or the one field. So I will just put there one. Okay, one. That is commonly used in your work problems. If they are finishing one field only, let's say they are finishing two fields, then that should be two. Okay, so that's it. The job, their speed. This is how fast they are, and the time, multiply speed with time. That is the number. Okay. So solution of that, okay, since again your variable is x only, we only need one. Okay, we only need one equation for that, so we can make use of that to solve. So all I need to do is combine this fraction here to make it a single number, isn't it? So LCD of 10 and 60 is 30. Okay, 30 divided by 10 is 3 times 1 is 3. 30 divided by 6 is 5 times 1 is 5. Okay, so this is now combined into 8 over 3 multiplied to x, so 8 over 3x, and then okay, equals 1. So actually you can apply here cross multiplication. 30 will multiply with 1, so that is 30. So you are having here 8x equals 30. Divide both sides by 8. You will have x equals 15 over 4, or in decimal that is 3.75 days. So what does that mean? If Brianna will plow it alone, she will be finishing it in 10 days. If Mika will plow it alone, she will be finishing it in 6 days. But if both of them will help each other, of course you will expect less than this number of days, isn't it? So that is 3.75. Okay? So again, checking, go back there, all you need to do is substitute. So 15 over 4, substitute there. Okay, this will combine into 8 over 30 again, multiply, that is a product of fraction. So numerator, numerator, denominator, denominator. So 8 times 15, 120, 30 times 4 is 120. That is equal to 1, which is equal on the other side. So we are 100% sure that our answer is correct. Okay, that is work problem. Okay, let's have third. Okay. How many gallons of a solution containing 80% of alcohol should be added to 5 gallons of a 20% alcohol solution to give a 30% alcohol solution? Okay, so we are talking here of percentage or mixture. We call that one, actually, this is a type of problem which is commonly known as mixture problem. If you are talking about a percentage of a certain chemical or substance in a mixture, that is mixture problem. So again, let's try to understand how many gallons of solution. We are talking here of how many gallons, that is the volume of a solution that contains 80% alcohol, should be added to a 5 gallons. Okay, that unknown there, we are going to add that one on a 5 gallons, and that 5 gallons is containing 20% alcohol only. And then that should give us, okay, if you will add that 80% alcohol of unknown number of gallons to that 5 gallons 20% alcohol, you will end up with a 30% alcohol solution. Okay, so that is the problem. So the question, how many gallons of that 8%? So in here, okay, it is also best to draw this one. I mean to write down a figure, but okay, this is just a joke. Okay, do not make this one serious. This is just a joke, just to get your attention. Okay, because I know that these things are actually uh, familiar to most of you, so I use this figure to just to get your attention, but this is just a joke. Okay? Don't be serious with this. Okay, so again, let's try to assume what is the unknown, the number of gallons of solution containing 80% alcohol. Okay, so let's say, for example, this is the solution of 80% alcohol. The question there is volume. How many, or what is the amount of that in gallons? Since we are talking here of gallons, we do not know. So let's say that is X, the number of gallons of that 80% alcohol. So that alcohol is 80%. Okay. And then you're going to add that one into a 5 gallons, okay, 5 gallons of 20% alcohol, okay, 80% alcohol, 20% alcohol. If you are going to mix that one together, because they have different number of gallons, they have different volumes, and they have different concentration, we call this one concentration. What does that mean, by the way? Let's say 20% alcohol. It means that in that 5 gallons, or let's say in 1 liter, 20% of that 1 liter is alcohol. That is the meaning of that 20% alcohol. That is your concentration. Okay? That is the meaning of your percent. That is concentration. Okay, so again, the question there, if I will mix them together, they will combine together that X gallon and then 5 gallons. If I will mix this together, of course, this number of gallons plus that number of gallons, nothing will be wasted because we will be mixing all of them. Okay, let's say that however in chemistry, actual chemistry, there will be maybe evaporation, so on and so forth, but let's consider this mixture will not be what to call this one, having a waste. So this total here of mixtures of the components will be the same as the total of the result. So okay, this is the key concept that you need to understand in mixture problem. Okay, for mixture problems, the total amount of substance in individual components. If we say individual components, those are the one that we are combining. So these are the components. Okay. The substance, the total number of substance. We are talking here of the substance. What is the substance? That is your alcohol. Okay. So the total amount of alcohol in your individual components, which are these, should be equal to the total amount of alcohol in the resulting mixture. Nothing will be changing there. The amount of alcohol in all of these mixed components, if I will mix them together, is still the amount of alcohol on the total resulting mixture. Okay, so that is the key concept that you should not forget in your mixture problem. You might be talking here of different substance, but the concept is still the same. Okay, so you should not forget about this. Okay, concept. So again, in this X, which is we do not know, number of gallons, the alcohol is 80%, and that 5 gallons, the alcohol there is 20%. If I will mix them together, it says in the problem that will end up with 30% alcohol. But the question, we do not know how many gallons should be that 80% alcohol, so that you will end up with exactly 30% alcohol, mixing that with this one. Okay? So, okay, what is our working problem? Again, it says there, make use of your concept. Okay, it says there that the amount of substance in the component should be the same on the mixture. Okay, so let's try to find out the amount of substance here. That is what we will be concentrating to create your equation. The amount of alcohol in your component. So it says there 80%. If we say 80%, so all of that 80%, the 80% of that X gallons will be the amount of alcohol here. The 20% of that 5 gallons is the amount of alcohol here. If I will add them, that is the total amount in these components. And then that should be equal to the 30% of the total summation of your volume here. Okay, 30% of that summation of volume is the alcohol in the resulting. So okay, that is what we will be using. Okay, 80% or 80% that is in decimal 0.8 of the X gallons plus 0.2 of the 5 gallons, isn't it? That is percentage. And on the other side, that should be equal. If I will add the 0.8 of X and 0.2 of 5 gallons, that should be equal to 0.2 of the total. If I will mix this X gallons to 5 gallons, they will just add, isn't it? So, if that is X, that is 5, the total amount will be X plus 5. Okay, so the alcohol there is 30%. So, 0.3 times that X plus 5 gallons. Okay, so again, you have one equation. This is your working equation. And you have only one variable, so you can just proceed. Okay, so 0.80x, 0.2 times 5 is actually 1. Okay, that is 1. Distribute 0.3 of x, and then 0.3 of 5 will be 1.5. Okay, you can now play around with that. Transfer 0.30 on the other side, it will become minus. Transfer 1 on the other side, it will become minus. So 0.8 minus 0.3 is 0.5. 1.5 minus 1 is 0.5 also. So divide both sides, that x will just be 1. What is that? Go back there. That is the use of your assumption. X is the number of gallons. Okay, so that is gallon. Okay, so x again is 1 gallon. That means you should mix 1 gallon of 80% alcohol to a 5 gallons of 20% alcohol for you to end up with 30% alcohol. What is the total volume of that? If that is 1, 1 plus 5, so the total resulting there volume is 6 gallons, and that will end up 30%. Why? Because the concentration here are different. Okay, the amount of alcohol in these components are different. So if you will mix them together, you will expect that the resulting amount of alcohol or concentration of alcohol is also different. Okay, so that is mixture problem. Again, do not forget of your K concept. So again, check, just go back there, substitute what is X, substitute, you will end up there 1.8 equals 1.8. Okay, if that's the case, then hindi ka pa garod lasing. So tama yung sagot mo, hindi ka pa lasing. Okay, joke, that is the joke. Okay, so that is the 3 problems in one unknown. Okay, in these 3 problems, we just use there one equation, one unknown. Okay, what if? Let's try to proceed to your system of linear equation. If you say system of linear equation, that means we will be having more than one variables and more than one equation. Okay, you should have there more than one variables and more than one equation. Okay, so let's have another example. Of course, let's just continue. So, but this time we will be having more than one equation and more than one variable. So example number 4. Okay, by the way, that example number 1 a while ago, here, you can solve that one using one unknown, and actually you can solve this one using more than one unknown, because you can say X there is received by Jones. You can make that one as Y, which is the amount received by Smith. So that is what we will be doing here. It is just another solution, but this time we will be using more than one equation. So okay, my assumption will just change. Let's say X there is the amount received by Jones, and then Y is the amount received by Smith. I will not yet introduce that difference, which is 25. Okay, so working equation, making use of this. X is for Jones, Y is for Smith. So there are 2 variables. So you need to create 2 equations. Okay, 2 equations. So first equation there is, okay, go back to the given. Those are your pointers for you to create your equation. So 350, what is that? That is the total sum of Jones and Smith. Okay, the amounts received by them. So if X is for Jones and Y is for Smith, then you will have the equation X plus Y, which is 350. Okay, again, you need to have another equation since you have 2 variables. So what else? There is another given that I did not yet use. So 25, it says there that Jones will have 25 more than Smith. So X Jones is the amount received by Smith, which is Y plus 25. That is another equation. Okay, X, the amount received by Smith, is equal to Y, the amount received by, X is Jones is equal to Y, the amount received by Smith, plus 25. Since it says there Jones is 25 more than Smith. Okay, you have two equations, two unknowns. So this is just simple. Isn't it? In linear equation, there are two ways: substitution or elimination. But what can you say here? The simplest here is substitution, because there are two equations and then x is already separated. All you need to do is substitute. But if you want elimination, why not? You can still do that. Okay, so by substitution, okay, I will substitute equation 2 since that is already arranged in your equation 1 directly. So the value of x will just become y plus 25. So in your equation number 1, substitute your equation number 2. So x will just become y plus 25. So that will be y plus 25 plus y still equals 350. Okay, so in this equation you only have one unknown, so you can now proceed. So y plus y is 2y. 25 will go on the other side minus. So 350 minus 25, that is 325. So 2y is equal to 325. Divide both sides by 2. You will have y equals 162.5 or 162.5. What is that? We are talking here of dollars. So $162.5. What is that? That is the amount. Y is the amount received by Smith. And then from equation 2, we need to find the amount received by Jones. Go to equation 2. Substitute 162.5 plus 25, that will be 187.50. That is the amount received by Jones. That is the same as our answer a while ago. Okay, so check that one the same. So that is another solution for your example number 1 a while ago. But this time we solved it using more than one variables. Okay, linear system of linear equation. Let's have two more examples for your linear systems of linear equation. Okay, so at present, John's age is 30% of his father's age. 20 years from now, John's age will be 58% of his father's age. How old are they? That is the problem. By the way, this is age problem, another type of problem solving, age problem. Okay, we are talking here of ages. Okay, so at the present, again, let's understand. At the present, or it means today, John's age is 30% of his father. And then after 20 years from now, it is there, John's age will now become 58% of his father's age. So the question there, how old are they? So the question is, how old are they right now? Okay? Walang sinabing after 20 years. So it's automatically, how old are they right now? So that is what I will be assuming. Let's say x is John's age today. Okay, y is the father's age today also. Okay, but in here in age problem, especially if you are talking about here more than two person, okay, you are comparing ages of more than two persons. This is a very helpful concept in age problem. Okay, key concept for age problem is to use the age table. Okay, that is for you to be easily establishing the equation or your relationships. This is what we call the age table. All you need to do is create there three columns. Okay, three columns. Past, present, and future, whatever the problem is. Okay, but we are talking here of the age at the present. So I will only fill up the table in the present. There is no such relationship which is given which is past. Okay, wala siyang sinabing before. Okay, so there is no data in your past column. This is age table. Okay, present says there the age of, okay, by the way I forgot to write there, but of course you already know since x there is John. This row is for John, that row is for father. Okay, you can write down there John father, so that you will not be what do you call this one, you will not forget. Okay, so again, there is no such given relationship in the past, so let's just focus in the present. It says there, what is the age of John and father at the present? John is x, father is y. Okay, in the future, what future are we talking about? After 20 years. So what will happen with their ages? So for John, x plus 20, that is his age for 20 years. And then for father, y plus 20, that is also the age of father for 20 years. For example, okay, there is a given scenario on the past. Let's say before for the past, let's say, for the past 10 years. For, let's say, for example only, but not in this problem. Okay, for example, for the past 10 years, we are talking here for the past 10 years. So you can fill this up into x minus 10. That is past, isn't it? So if the age at the present is x, then the past, let's say we are talking here of past 10 years, that will be x minus 10. And here will be y minus 10. So that is how you will accomplish your age table. Okay, age table. This will help us. Okay, this will help us formulate our working equation. But again, if you can just figure that out, why not? But again, especially if you are talking here of 3, 4 or more people or individuals wherein you are comparing their ages, it is always better to write down that in tables. Okay, or use the age table. All you need to do is create past, present, future. What happens? What is the age today? What happens on the age after this one, or on the past years? What happens on the age on this in the future? Okay, so fill this up, accomplish your age table. That is what you will be using for the working equation. Okay, so let's make use of this of the problem to formulate and at the same time your table. So it says there that at present, so we are going to make use of the present column. Okay, at present, John's age is 30% of his father's age. So that is the first equation. At the present, okay, John is 30% of father. So John, which is x, is equal to 0.3 of y, which is father's age. Okay, equation 1. You need to create another equation since there are two unknowns. Okay, so what else? Let's proceed. 20 years from now. So that is now in the future, after 20 years. So that is where we will be getting your second equation. So 20 years from now, John's age will be 58% of his father's age. So what is John's age after 20 years? That is x plus 20. That is equal to 58% of father's age, which is y plus 20. So 0.58 of y plus 20. Okay, equation 1, equation 2. You have now two equations. You are now ready to solve that one. Okay, so what will I do? Again, it is better for me to apply here substitution since equation 1 is already expressed, wherein x is separated. So substitute equation 1 to equation 2. Equation 1, equation 2, substitute that one. So in equation 2, x will just become 0.3 of y. Okay, so x there will be 0.3 of y plus 20 equals 0.58y. Okay, distribute that one, 0.58y. 0.58 of 20 is 11.6. Okay, so now we have one equation, one unknown. You can solve y and then later on solve for x. Okay, so first, let's say 0.3 will go together on your 0.58, but it will become minus. Okay, 0.58, this 0.3 will go minus. Okay, so we have here 0.58 minus 0.3. Okay, you can do that one on this side or you can interchange at the same time. It's up to you. This is now simple procedure of algebra. Okay, that 11.6 there is number, so put that together with 20. So that will go minus on the other side, together with your 20. Okay, 0.58 minus 0.30 is 0.28. 20 minus 11.6 is 8.4. Divide both sides by 0.28, you will have their y equals exactly 30. So what is that? Father's age. So father is 30 years old. Okay. And then from equation 1, go to equation 1, substitute your y, which is 30 times 0.3, that is 9. So what is that? X. X is what? John's age. So it means that John is 9 years old today and father is 9 years old today. So after 20 years, so that is 20 plus 9 and that is 30 plus 9, John's age will be 58% of father. Okay, you can check that one. So again, checking, always have checking. So let's say we used here equation 1 to solve for the other unknown. So maybe I will be using here equation 2 to check that one. Because of course, if you will go back to equation 1, that is where we solved your second unknown. So automatically that will be correct. But to make it right, I will use equation 2. So be 100% sure I will make use of the other one. So make use of equation 2, substitute x and y, substitute their x and y, play around. 9 plus 20 is 29, 30 plus 20 is 50, 0.58 of 50 is 29 also, therefore we are 100% correct. Okay, another example for a system of linear equation. Let's have one more before we will proceed to unit 2. Okay, this is actually a work problem. Again, another work problem. But this time we will be having here, we cannot solve this one alone by one unknown. A while ago, this one is solved by one unknown since we can, there is only one unknown there in the work problem. But again, that example later is still work problem. So we will still consider here your K concept, which is again, we will consider 1 day if we are taking here of days, 1 week, 1 month, 1 hour if we are considering those time interval. Okay. So example number 6. Here, let's try to understand. Let's try to understand it first. Okay, let's try to understand that one. Okay, so when A and B work together, so we have here 3 workers, A, B, and C. When A, B, and C work together, they finish installing a garden in 3 days. So the work there or the job is to install a garden. Okay, so there are 3 workers, A, B, and C. And if they will work together, they will finish installing the garden in 3 days. Okay, the job could be completed. Okay, so again, that could also be done. Okay, that is the meaning of that. That could also be done if A work 4 days alone and then C work 10 days alone. So it means they will help together. A will work for 4 days and then C will work for 10 days. That will be also installed. The garden will also be installed. Or another situation here, B will work 5 days alone and C will continue for 3 days alone. Okay, so there are 3 situations here. It's either A, B, and C will work together. They will finish that job in 3 days. And the other situation is that A will work for 4 days and C will work for 10 days. They will also complete the same job. Or the third situation there is B will work for 5 days and then C will work for 3 days. They will also finish the same job. Okay, now, how many days would it take each worker alone to complete the job? Now the question, what if they will work alone, one-on-one? So let's say A will work alone. How many days will A finish the entire garden? And then if B will work alone, how many days will B work alone to finish the entire, and then C, how many days to finish the entire garden? So that is the problem. There are 3. How many days for X alone, for A alone, and then how many days for B alone, and then how many days for C alone. There are 3 unknowns. So let's say that is my X, Y, Z here. So X for number of days for A to complete the garden alone, and then Y for B, and then Z for C alone. Okay, so those are my assumptions. So again, this is a work problem, so we will consider what they can do in 1 day. Okay, so let's consider what they will do in 1 day. So if X can finish that one in how many days? That is the unknown, so that is X. So what does that mean? In 1 day, what part will A finish? 1 over X, that is the meaning of that. That 1 over X here is what will A finish in 1 day, since we do not know that total number of days for A to finish the job. And then of course, 1 over Y, that is the amount of work B will finish in 1 day. And then 1 over Z, that is the amount of work the worker C will finish in 1 day or so. But since in the first situation, let's first create the first equation. So first scenario, they will work together. So 1 over Y plus 1 over X plus 1 over Z, they will be added together since they will work together. So if I will add all of this, again, these are the rate for 1 day. This is what they will finish in 1 day, all of them. If I will add all of that, it means they are working together. And it says that they can finish that garden in 3 days if they will work together. So multiply what they can finish, all of them, what they can finish in 1 day, multiply that one for 3 days, then they will finish the one job. One job, because it says there just to finish the garden, but it's what, but for example, let's say they will finish 3 gardens, that should be equals 3. However, again, we are only talking here of finishing the garden, one garden. So one job, so equals 1. So again, okay, let me just simplify that for you to have the equation. Multiply that one, distribute, so of course that will just be 3 over x over plus 3 over y plus 3 over z equals 1. That will be our equation 1. Okay, second scenario, okay, it's either it is for A and C to work. So first is A will work for 4 days alone. Mag-isa lang siya. So only A will work for 4 days. So 4 days times what will A finish in 1 day? That is 1 over x, isn't it? 1 over x. And then another 10 days, but that is for now C to work alone. So 10 times what will C finishes in 1 day, which is 1 over z. And that will also complete this one job. So simplify 4 times 1 over x or 4 over x. That will be 10 over z equals 1, another equation, equation 2. And then the third scenario is B and C will work. So B will first work for 5 days. So 5 times 1 over y, that is the rate or how fast or what will B finishes in 1 day. 5 times 1 over y, and then 3 days for C, isn't it? So 3 times 1 over z, and they will also finish the same job. So simplify, this will be the resulting. So we have 3 equations, 3 unknowns. 3 unknowns since we are talking of x, y, z. 3 equations, we have 3 equations. Okay. So I think in this process you cannot make use of substitution. You can do that, but that will be a very, very complicated solution. So I'd rather suggest here elimination. Okay. So again, in elimination, all you need to do is choose a variable to cancel, eliminate that one, so that you will reduce the number of from 3. Eliminate one variable, you will have 2. You have 2. What do you call this one? Left, and then eliminate one more. You will only have 1. Okay. So that's what we'll be doing. So decide. Let's try to look here. Get pair by pair again by elimination, pair by pair. Okay. So let's try to look here. Okay. So let's say I will pair equation 1, equation 2. I will eliminate x. So you will only expect their y and z. And then in your equation 3, it so happen that you only have their y and z. So at only one elimination, you already reduced that one to 2 unknowns. And do the same, you will end up 1 unknown. Okay. So eliminate, let's say I will decide to eliminate x. But I cannot do that since actually their values are not the same. I mean their coefficients are not the same. This is 3, that is 4. They cannot just cancel if I will subtract them. So what will I do? Okay, again I decided to eliminate x. So what will I do for them to be the same so that if I will subtract they will cancel? I will, let's say, multiply equation 1 by 4. Okay, equation 1 by 4, and then equation 2 by 3, so that I will just be interchanging their values so that they will be the same. So again, subtract 3 times equation 2. So I will multiply equation 2 by 3 so that that will become 12. Subtract that one from, okay, 4 times equation 1. I will multiply 4 with your equation 1, so that will also become 12. So now that will end up 12 and 12, they will now cancel. Okay, so that is what we will be doing. So equation 1 first, multiply 4 here, so that will be 4 times 3 times 3 times 3, 4 times 1. Okay, so that's it. That will become 12 over x plus 12 over y plus 12 over z equals 4 times 1 is 4. Okay, we are multiplying 4 in your equation 1. And then multiply 3 in your equation 2. So that will be 4 times 3 is 12 also. And then 4 times 10 is, 3. 3 times 4 is 12. And then 3 times 10 is 30. And then 3 times 1 is 3. But of course, just like in adding, in subtracting, only subtract or only combine those with the same variable. So I will only put there below those who are the same. But do not forget that is subtracted for this to cancel. Okay, so if I will subtract that, this 12 over x will cancel, so x will now be eliminated. Okay, so there is nothing to subtract from 12 over y, so that will just go down. And 12 over z minus 30 over z. Okay, so they are the same fraction over z, so all you need to do is subtract their numerators. 12 minus 30 is negative 18, so that will end up negative 18 over z. So 4 minus 3 is 1. Okay, so we have now a new equation. Let's call that one another name because this is a combination. So it is not just an equation that is rearranged. So we will be naming that one a different name. So equation 4. Okay, so that is now a variable of y and z. It so happened again that in your equation 3, that is now y and z. So we already reduced your system into two unknowns. So okay, I will continue that on the next slide. So what will I do now? Okay, you have now equation 4 and equation 3, which is in terms of y and z only. So I will decide again another variable to eliminate. So let's try to focus. Okay, in y that is 12 and that is 5. So I think there is no similarity. I need to multiply that one by 12 and by 5. So I think I will not be cancelling y. If I will look at z, z is 3 and 18. Actually, they are number divisible by 3. So maybe I will cancel z. But it's up to you. You can cancel y. You can decide that one. But you need to make them the same. Okay. So what will I do? I will cancel z. So what will I do? That is 18. So all I need to do is multiply 3 by 6. So multiply equation 3 by 6 so that they will become the same since I decided to cancel z. So that is what will I do. I will add since they are different signs, so they will cancel. So I will be applying addition. But first multiply equation 3 by 6. So add the 6 times equation 3 and add that one to your equation 4 for us to cancel z. Okay? So multiply 6 in this one, so that will be 6 times 5 is 30 over y, and then this will be 18 over z. 30 over y plus 18 over z, and then of course 6 times 1 is 6. And then of course copy your equation 4. Just copy that one. This is your equation 4. Now I will add. Since they are different signs, if I will add, they will cancel. If they are the same sign, what will I do? Subtract. Okay. So add. This will now be eliminated. But 30 over y and 12 over y will now end up 42 over y. Okay. If I will add this one, this will now be 42 over y. And then 6 plus 1 is 7. Okay. Play around. Solve for y. Cross multiply. Put that y on top. So cross multiply on the other side. This number, I do not need that. So put that one below or divide both sides by 7. Pupunta yan sa baba. So y is equivalent to 42 over y. Or 42 divided by, 7. 42 divided by 7 is 6. What is y? Go back there. We are talking here of the number of days for B to complete the garden alone. So that should be days. So 6 days. It means that B will finish that garden installation in 6 days only. Okay. Now I need to find out y and z. So equation, what will I use? Maybe equation 4. So from equation 4, this is your equation 4 a while ago. So 12 over y. So y will just become 6 minus 18 over z still equals 1. So play around with that. 12 over 6 by the way is just 2. And then of course I need to separate that with variables, so this will go positive on the other side. 1 will go together on the constant on the other side, but it will change into minus. So again, 12 divided by 6 is 2. That will be minus 1, so that will be 1. 18 over z. Now, cross multiply z on the other side. 1 will go down. So z, 18 divided by 1 is still 18, so z is 18. So it means that your worker C will finish that one in 18 days. So, mabagal siya. Mas mabilis si Y. 6 days lang siya matatapos. And then I need to find out X, how fast or the number of days A will finish the job. So, where will I get that one? Maybe go back again to the equations. Where will I find X? I cannot find that equation 3. Maybe I can use equation 1 or equation 2, but this is very long. So, maybe I will use equation 2. from equation 2. Okay, so in your equation 2, that is 4 over x plus 10 over what is that? 10 over z. So however, we already know z to be 18 equals 1. So again, 10 over 18, that is a number. Okay, that will go minus on the other side. You will be left here with 4 over x. 1 minus 10 over 18, make that one the same. Combine this one. LCD is 18. So 18 over 18 minus 10 over 18. 18 minus 10 is 8. So your resulting here is 8 over 18. We want to find x, so cross multiply x on this side. 18 will multiply with 4, so 18 will be multiplied with 4 to be 72. And then of course 8 will go down, so x will just be there alone. So x is 72 over 8, or that is 9. So that is 9 days. So again, look at these values. So again, worker A, because that is the x. A is x, B is y, C is z. So worker A will finish in 9 days, worker B will finish in 6 days, while worker C will finish in 18 days. So they have different speed. Okay. So again, let's try to check that one. What equation did I not yet use? I use equation 4 to solve your z. I use equation 2 to solve your x. I also use here your equation 3. So maybe I did not yet use your equation 1. So I will use equation 1 to check that one. So 3 over x, 3 over y, 3 over z equals 1. 3 over x, which is 9. 3 over y, which is 6. 3 over 18, which is over z, which is 18. LCD of this, 9, 6, and 18. What is the number that could be divided by this? Actually, that is 18. So 18 divided by 9 is 2, multiplied to 3, that is 6. 18 divided by 6 is 3, multiplied to 3, that will be 9. 18 divided by 18 is 1, so that will remain 3. 9 plus 3 plus 18, plus 3, 9 plus 6 plus 3 is 18. 18 over 18 is 1. So we are correct. Okay, that's it. That's it for Unit 1. Linear equations. Okay, so you will only have the x, y, z, or only x. Depends if you can express that one in one equation, one unknown, better. But if you cannot do that, you need to use more than one variable, then that will be systems of linear equation. Now that is your Unit 1. Okay, so now we will proceed to your Unit 2. But by the way, before proceeding to your Unit 2, you have here your activity. This will now be your assignment 3M, since you had 2 more assignments before. So this will be your assignment 3M. Please do this one. So we will now proceed with your Unit 2. Okay, Unit 2. Okay, so Unit 2, application of quadratic equation. So quadratic na tayo. You will expect their exponent, which is 2. Okay. So in this again unit, the same. You should be able to translate worded problem into equation. And of course, we will be dealing with problem solving that has something to do, or that has equation which is quadratic. Okay, so maybe let's just have 2 examples only for this, since the procedure is the same, only that different equation, different degree of equation. So first problem, find 2 consecutive odd integers whose product is 1023. 1023 or 1023. So 2 consecutive integers. Please take note of this. This is a common problem. We are talking of integers. So if we say integers, that could be a positive or negative number, okay? But please do not forget of this. There is a description for that integer, add. We say add, these are, for example, of odd number is 1, 3, 5. Okay, if you say consecutive, these are odd numbers that are preceding with each other, or they are succeeding with each other. Okay, magkasunod sila, following each other. So again, add, so that means that let's say 1, 3, 5. So maybe let's say 3 and 5. They are consecutive odd integers. So that is example. Maybe in other problems that will just be integers. So if you say integers, no problem. That could be 1, 2, 3, 4, 5. It is just a consecutive, negative or positive. And other problems that could also be even. So if you say even, that is 2, 4, 6. Okay, please take note of that. But here we are talking about odd integers. So it is a number. By the way, odd is a number that could not be divided by 2. That there's a remainder if you will divide by 2. Even is a number are numbers that could be divided by 2 with an answer which is whole number. Okay, so find two consecutive. So there are two numbers, odd integers, that we are going to find. And if you are multiplying that one, that will end up with 1023. So first, let's try to by the way, if you want to create quadratic equation, you should only use one variable. Okay, quadratic equation, only one variable. Okay, consecutive odd integers. So let's say x is the first integer, odd integer. We are talking here of odd integer, guys. Okay, odd integer. And then, of course, if that is the first odd, then what is the second? They are consecutive. Okay, they are following each other. So if x is the first number or integer, then x plus 2. Why is it plus 2, not plus 1? Because we are talking of odd integer. So if you say add, so there is a number between these two. There is a number between. So their difference is 2. Just like for even, let's say we are talking here of even integers, there is a number between, isn't it? Because add, even, add, even, add, even. So if you are considering 2 odd, there is an even between. If you are considering 2 even, there is an odd between. Okay. However, let's say you are just talking about integers, then the difference is only 1. Since you are just talking here of integers, it could be odd or even. Okay. So that is again x plus 2, since we are talking here of odd. That is your second integer. And if we are going to multiply that one, they will end up 1023. So all I need to do is multiply this one for us to have your working equation. X times x plus 2. So if I will do that, x squared 2x. That's why you have there x squared. You are now dealing with quadratic equation. Okay. So play around. How do we solve quadratic equation? There are three. By factoring. You cannot just do that one by factoring. If you cannot figure out the factors, completing the square. But if you want a derived formula of completing the square, quadratic formula. Diba? Three ways. But actually in here, you can just do that one by factoring. Okay, so for me, before I will do factoring, I will first transfer that 1023 on the other side. It will be negative 1023. So I figured this out already. The factors of that is x plus 33 and then x minus 33. You can check that one by multiplying. This will end up there. So again, how are we going to solve that? Equate each of the factor to 0. So if I will equate the first, x plus 33 equals 0, 33 will go negative on the other side. So your first value of x, which is negative 33, the value is negative 33. Now we need to find the second integer. It says there x plus 2. So x1, let's say that is x1 because we will be having another x later on. So let's say x1 is negative 33. And then plus 2, negative 33 plus 2 will be negative 31. Okay, this is a negative. So it will be subtracting. So negative 33 plus 2 is negative 31. So you can check that one here. Negative 31 times negative 33, will that give us positive 1023? Yes. So that is correct. But there is another solution. Equate your x minus 31 to 0. You will have x equals 31. Okay, positive 31. So let's say that is x sub 2. That is the second value of x. Get the second integer of that. So 31 plus 2 is 33. So a while ago, we have at negative 31, negative 33, which is proven to be correct. Now we have 31 and 33. Let's try to prove that one. That will be the same because, of course, the same number, only that this is negative, negative. This is positive, positive. But, okay, are they the same? Are they considered both as correct? Yes, because there is no specification there. Let's say if in the problem it says there, find the positive, then your answer is the positive one. Let's say find the negative, your answer is the negative one. Therefore, the answer here is the integers are negative 31 and 33 or positive 31 and positive 33. Okay, that is for example number 1. Example number 2. Okay, example number 2. The base of a triangle is 4 feet shorter than its altitude. Okay, we are now dealing here with triangle, but actually we did not yet proceeded with your trigo. However, you have a very basic knowledge in your trigonometry, isn't it? Before, I know that one. You have a basic idea in your triangles. Okay, so the base of a triangle is 4 feet shorter than its altitude. If you say base, that is of course the one that is landing or parallel to horizontal. And then the altitude. If you say altitude, that is a 90 degrees. That is a perpendicular with your base. So if that is your horizontal, then the altitude is your vertical. From the base to the highest point of the triangle. By the way, in triangles, there are types. Right triangle or irregular. So let's just consider any. Okay, so let's try to understand. Base of the triangle is 4 feet shorter than its altitude. And the area is 126 feet squared. Find the base and the altitude. So let's try to find the dimension. So, okay, I will create here figure because maybe this will help me. Okay. So let's say y there is the altitude. It's up to you. You can say that x is the base. So it's up to you how you will do this one. But for me, let's say y is the altitude. Because later on, it says there that again, this is a quadratic equation. I want to create quadratic, so I will be using one variable. Since I already used their y, I will be using y for the base. But it says their base is 4 feet shorter than the altitude. So if that is y, your base is 4 y minus 4. That is our base for the triangle. Okay, this is the basic knowledge. I already gave it here. For the area, since we are talking here of area, the area of a triangle is 1/2 base times altitude or base times height. Okay, but you need to make sure that your height is always perpendicular to the base. Okay, so that's why in a right triangle there's no problem for the altitude because the altitude is the same as the height automatically. So 1/2 base times height, but our base here is y minus 4. And then multiply that one with your height, which is y. So that is 1/2 y times y minus 4. So that is our area. So for us to create our working equation, let's make use of the given. It says there the area is 126 feet squared or square feet. So that equation here, we will equate that one with 126. Then that is your working equation. But first, let me first simplify our working equation. So what will I do to get rid of the fraction? Actually, I can multiply both sides by 2 or cross multiply 2 on the other side. So y will be there to be y squared, y will be there to be negative 4y. But your 1/2 again, you can cross multiply that one or multiply both sides by 2 para mawala yung 1/2. And that 126 will become 252. So this is now a quadratic equation. This will go minus on the other side. Then actually I can just do that one by factoring. And my factor here is y plus 14 and then y minus 18. You can check that one. Okay, you can check that one. And then equate each into fractions. I mean to 0. Sorry. Okay, so equate your y plus 14. You will end up with y. The first value of y is negative 14. Negative 14. What is y? Go back there. Altitude, that is a distance. Is there such as negative distance? If we are talking here of a triangle, there is no negative distance. So all I need to do there is neglect that one since there is no negative. So that is the important that you need to consider in your problem solving. Once you ended up with a value, try to analyze if that value that you solve is reasonable for the certain problem. You are talking here of distance and you ended up with a negative. Is there such a negative distance? Maybe if you are on physics, since you have a negative distance, the negative means opposite direction. But here, Okay, there is no opposite direction here. So we are only talking here of distance. So that should be always positive if you are talking about distance. So therefore, again, negative, you can neglect that one. Forget about that one. Okay. So how about the other one? Equate your y minus 18 to 0. That will be y equals 18. That is okay. A while ago, by the way, you ended up with a negative value. That is okay because we are talking here of integer. If you say integer, there's a positive, there's a negative. It's okay. But for this example, negative is not okay since that is distance. Okay, so neglect that negative 14. Use the other one, y minus 18 equate to 0. You will end up with y equals 18. That is also feet since we are using here distance, which is feet. And what is that y? That is your altitude. And then what do we need again? We need to solve also your base, which is y minus 4. So y minus 4, 18 minus 4 is 14 feet. That is your base of triangle. Okay, you can now check that one. It says there that the area is 1/2 base times height. So 1/2 base is 14, height is 18. So multiply that one, that is 126 feet squared. Then we are correct. Okay, we are correct. So that's it. For this is the last topic that we will be having since we already applied your concept of algebra into problem solving. This is the last topic that we will be having in your algebra. There are a lot actually of topics in algebra, but these are the important that we should be discussing in your bridging mathematics. Okay, so if you have a question, comment that one below the video. By the way, do not forget there is another activity here. A while ago in your linear equation, you have there assignment 3M. In this one, you have another assignment 4M. This is actually to be submitted separately. Okay, separately. Please answer this one also. So if you have question, comment that one right away below the video. Okay, that I will answer that one. But if we cannot answer that one by comment, then we will be discussing that one on the next live video. So thank you very much for listening and watching.